All right. Before moving on to multiplying and dividing scientific notation, make sure you understand how to use scientific notation with adding and subtracting. If you're having trouble with the adding and subtracting, please send me a remind so that we can get on a Google Meet and have a quick tutoring session. Or make sure you save or jot down any questions you have so you can ask me during your A or B blocked schedule, and we can go over some on the board. All right, so this slide is dealing with multiplying and dividing scientific notation. So this is a little bit easier than adding and subtracting because you're not having to go back into standard form and then back in to scientific notation because your bases no longer have to match, all right? You just have to remember to either add or subtract based off if you're multiplying and dividing. I'll be honest, in chemistry, multiplying and dividing is the big one that you need to be able to do. We don't do a whole lot of adding and subtracting in scientific notation. We deal with mostly multiplying and dividing. Okay, so with multiplying and dividing, you've got to remember which one you're going to add and which one you're going to subtract, okay? All right. So again, I have the problem approach steps here in the center, and I'm going to work through 2 sample problems to show you how we do this. All right, so with multiplying, you're going to remember we are going to add our powers. Okay, so when we're multiplying, we are going to add our powers right up there, the 3 and the 6. Now remember the way you would add or subtract with negative numbers, okay? All right, so here we're dealing with 2 large numbers, and I know they're large numbers because my powers are positive. All right, so the first thing you're going to do is you're going to find the product of the coefficients. So my coefficients are 2.5. I'm going to multiply that by the coefficient right here, 3.2. Okay, so when I get that answer, I'm going to plug that in the calculator. You, of course, can do it longhand on the paper. Maybe try one that way just to, get your brain working. But I'm going to get 8, and it's 8.0. Okay? All right, so I get 8.0. Now, that's going to tell me the coefficient, all right, of my scientific notation, okay? So the next thing I got to do is I got to figure out what my power is going to be when I multiply these 2 numbers. So when multiplying with the base 10s, all I'm doing is adding my powers. So I'm going to add I'm going to bring that down here. I'm going to add 3 plus 6. So that's going to give me 9. So my new power is 9. Now the nice thing with this answer here is it's given in the proper notation. Notice I only have 1 number in front of the decimal, and then I've got my times 10 to the power. So I am done. This is already simplified and in the right format. Okay, so that is multiplying with scientific notation. All right, let's take a look at what does it look like. Get a bigger eraser here. What does it look like when we're dividing? Okay, well, when we're dividing, we are going to be subtracting our powers. Okay. All right, so the first way you approach this problem is you're going to go ahead and worry about the coefficients first. But there's not a coefficient with this base 10. Whenever you see the absence of a coefficient, and this is going to be true for all the coefficients you're going to see in chemistry. So there's going to be coefficients in front of elemental symbols. There'll be coefficients in front of elemental symbols when you're balancing equations. You may not see one. And whenever you don't see a coefficient, you need to remember that what it means is 1 times 10 to the 6. All right, so if you had 10 to the 9th by itself, it means the same thing as 1 times 10 to the 9th. All right, so when you see an absence of a coefficient, it is understood that that number is 1. All right, so when I write this out, I now have 9.4 times 10 to the negative 4 divided by 1 times 10 to the 6. Now, if you go back and you can also remember, we could also write this as 9.4 times 10 to the 4, and we can write it in a fraction form. Okay, so you may see it like this as well. That means the same thing. Okay, we're going to divide. So we're going to take this and we're going to divide this first. So we're going to find the quotient of 9.4 divided by 1. And we know whenever you divide anything by 1, you get the same number. So I'm going to get a coefficient of 9.4. Now all we have to do is figure out the powers. So here I have -4 minus 6. Okay, so I'm going to go back here and remember how we do this. If you remember, when you're minusing with a negative number, you just change this into a plus sign and then add a negative sign. So -4 plus -6 is going to give me -10. So my new power is -10. Now, if you look here, we like this. We're nice and happy because we're in a simplified form. We meet all the qualifications of being scientific notation. We have one number in front of the decimal, which is the 9, and then everything else falls right into place. So our answer is 9.4 times 10 to the negative 10. All right, so on the next couple slides, you're going to practice doing this. Make sure you write out all the steps like you did when you were practicing addition and subtraction.